question is a paper 2 style question. Paper 2 questions tend to be longer and tend to move through various topics. So we need to be careful here and read the question really carefully in case it moves into a different direction. Okay, so we need to be especially careful at reading questions on paper 2. So this particular question is clearly looking at statistics, and if we keep reading down, we can see that it looks as if it's going to be scatter graphs and correlation. Okay, so that's what I'm keeping in mind through the question. So this is part of a Maths IA, and they've investigated the time taken to read the book. So the data is given to us in this box and whisker chart, okay, and we need to state which of the two sampling methods, either the systematic or the quota, that he's used. Okay, so it says there, we highlight the key information, that he collected his data by stopping and asking students in the school corridor until he reached his target of 10 students. Okay, and that was from each of the literature classes in his school. Okay, so each of the literature classes. So that means that it is what we call quota sampling. Systematic would be if he asked every 10th person, every 12th person, and so on. Whereas this is quota sampling, he's took a sample from the different quotas from each of the literature classes. Okay, so this type of sampling is quota sampling. And then for part B, we have the box and whisker diagram, and we need to write down the median time of reading the book. So a box and whisker has the median in the middle. So this is the median here, and therefore the median is 10. Then we need to calculate the interquartile range. So the interquartile range is found by doing Q3 minus Q1. And if we look at the box and whisker graph there, we can see that Q3 is 15 and Q1 is this value here, which is going to be 7. Okay, so 5, 6, 7, 8, 9, 10. So we can check the scale. Okay, so this value is 7. So it's going to be 15 minus 7, and that gives me a total of 8. So my interquartile range there is 8. Then it says that there is a member, Mackenzie, who took 25 hours to read the novel, and they're trying to work out whether or not she's an outlier. So an outlier is found by doing the interquartile range times 1.5, and then we add that to the upper quartile and we subtract it from the lower quartile to find what the boundaries are. Anything outside of that becomes an outlier. So it's 1.5 times the interquartile range. So to determine whether or not Jason is correct, it's unlikely to be, in fact it's impossible, to be an outlier on the smaller end, okay? Because it would be somewhere down here, and it says that she's 25, okay? So we're obviously looking at the upper limit. So if we do 1.5 times the interquartile range, and then we're going to be adding it on to the upper quartile. So 1.5 times 8, which was my interquartile range, is 12. The upper quartile was 15. So I'm going to do 15 plus that 12, and that will give me my upper limit, which is 27. In which case, if she's 25, she's inside that limit. Okay, so she is not an outlier. So not an outlier. And therefore Jason is correct. And then for each of the students interviewed, they've recorded the time and they've recorded the percentage that they scored in the exam. Okay, so we're trying to describe the correlation, and the correlation there, the key word that I'm looking for is negative. Okay, we can see that it's a negative correlation where the data has got a negative gradient. Okay, positive would be increasing. So they calculate the equation of the regression line, and that's given to us here. And we're going to use it to estimate the percentage when a student read the book in 1.5 hours. So 1.5 hours is somewhere down here, and we can then work out the percentage. Okay, so the time is equal to minus 1.54 times 1.5 plus the 98.8. So I'm literally just substituting in my x value as 1.5. Okay, the x is the time taken, and we're told that that's 1.5, and that gives me a value of 96.5. So 96.5%. Then we need to decide whether it's valid. It is not valid. Okay, so it's not valid. The reason for that is because it's extrapolation. Okay, so extrapolation is the key word that you want to write there. We don't have any values less than whatever this value here is, so 5. So our data kind of fits between these two values. So if we're using it for something down here, it's outside of our range of data. Okay, so it's extrapolation. And then we've got the last question. So they found the website with the top 50 books, and we have the information on there. So it's the number of pages versus the ranking or the rating that they've got. And we're going to be using Spearman's rank correlation, which makes sense because the data's been ranked. So Spearman's rank. And we need to, first of all, fill in the table, which is the rank of the number of pages and the rank of the top 50 selling. So we're now going to fill out the table where we're ranking both sets of data. So for the number of pages, I need to put them in order. So I'm going to start with the greatest number of pages. So we can see that it's wanting us to start that way because this is the biggest and they've labelled it as 1. So the next biggest is D, which is going to get place 2, and then B is place 3, G is place 4, and so on. So we're just going through and labelling all the different ranks. Okay, and then we're going to do the same for the top 50 rating. So obviously we haven't took all of the top 50 books. So this was the first place, this was the second place, this was the 5th place, but for us, it's the next best book. Okay, so it's actually in order at the moment, and it would just be listed like that. So we're now needing to find the correlation with the Spearman's rank. So we type our data into a spreadsheet on the GDC. So the first one is the rank of the pages, and the second one is the rank of the rating. Okay, so I'm just going to call it P and R. So the rank for the pages is 1, 3, 5, 2, 6, 8, 4, 7. And then the rank for the ratings is just in order as it is at the moment. So 1, 2, 3, 4, 5, 6, 7, 8. So to do Spearman's rank on the GDC, I now do statistics. So it's the same as doing PMCC, it's just that you type the rank into the information. So it's statistics calculations, and then it's the linear regression, mx plus b. So the X list of data is my number of pages, which I put as P. The Y list of data is the ranking. And then we click OK. And we can see there that the R value is 0.714 to three significant figures, so 714. And then the last one is to interpret the result. Okay, so that is a pretty strong positive or moderate positive correlation. Okay, so you would either get the mark for strong or moderate. So strong, moderate, or any other word that's meaning those same things. And the key thing is to put positive correlation. Okay, so that's the final interpretation there for the last part of the question.